Welcome to the fascinating world of magnets. Today we'll explore how magnets work, where we find them in everyday life, and the fun experiments you can try at home or school. Magnets are not just science tools, they're part of our daily routines, from holding notes on the fridge to helping cranes lift heavy metal objects. Let's dive in and discover the magic behind these mysterious forces, starting with a real-life scene at a junkyard where magnets make sorting metal easy and exciting. Imagine a crane moving over a huge pile of junk. As the crane lowers its arm, a block attached to it picks up pieces of iron effortlessly. This is the power of magnets in action. Magnets are used in industries to separate metals from waste, making recycling easier and more efficient. You might have seen similar magnets in pin holders or pencil boxes where they keep things organized and secure. These hidden magnets make everyday tasks simpler, and their presence is often unnoticed until you see them in action. Story of magnets begins in ancient Greece with a shepherd named Magnus. While tending his sheep, Magnus noticed his iron-tipped stick was attracted to a special rock. This rock, later named magnetite, was a natural magnet. People realized that certain rocks could attract iron, and these natural magnets sparked curiosity and discovery. Over time, humans learned to make artificial magnets, which are now used in countless ways. The journey from natural magnetite to modern magnets is a tale of observation and innovation. Natural magnets like magnetite are found in rocks, but artificial magnets are made by humans from iron and other materials. Artificial magnets come in various shapes: bar, horseshoe, cylindrical, and ball-ended. Each shape has its own uses and properties. Today, artificial magnets are everywhere, from toys to tools, making life more convenient and fun. Understanding the difference between natural and artificial magnets helps us appreciate their unique roles in technology and daily life. Magnets are made in different shapes to suit various purposes. Bar magnets are common in classrooms, horseshoe magnets are strong and compact, and cylindrical or ball-ended magnets are used in specialized equipment. The shape of a magnet affects how it interacts with other objects and its strength. By experimenting with different shapes, scientists and engineers can design magnets for specific tasks, from lifting heavy objects to creating precise medical devices. Let's try a simple experiment. Place a magnet inside a cup and cover it with paper so the magnet is hidden. Attach a thread to an iron clip and fix the other end at the base. When you bring the clip near the cup, it rises in the air, seemingly without support. This magical effect is due to the hidden magnet attracting the iron clip. Such experiments help us understand the invisible forces at play and make learning about magnets interactive and fun. Magnets attract certain materials, but not all. Iron, nickel, and cobalt are magnetic; they stick to magnets. Other materials like plastic, wood, and glass are non-magnetic and do not get attracted. By testing everyday objects with a magnet, you can discover which materials are magnetic and which are not. This knowledge is useful in sorting materials and understanding the properties of different substances. You can create your own magnet stick by attaching a magnet to a stick and exploring your surroundings. Test various objects, coins, keys, pins, and more to see which ones are attracted to the magnet. Record your observations in a table and compare results with friends. This activity helps you learn about the materials used in everyday items and their magnetic properties. Magnets can help find lost metal objects like a needle dropped on the floor. By moving a magnet over the area, the needle will stick to the magnet, making it easy to locate. This practical use of magnets saves time and effort, especially for small items that are hard to see. Magnets are handy tools for tailors, carpenters, and anyone working with metal parts. By rubbing a magnet in sand or soil, you can check for the presence of iron filings. Some particles stick to the magnet, indicating iron content. This experiment can be done in different locations to compare soil samples. Iron filings are tiny pieces of iron that show how magnets attract even the smallest particles. This activity reveals the hidden magnetic materials in our environment. When you spread iron filings on paper and place a bar magnet underneath, the filings arrange themselves in unique patterns. More filings stick near the ends of the magnet, called poles. This visual experiment helps us understand the magnetic field and the strength of magnets at different points. Drawing these patterns shows the invisible forces that shape the world of magnets. Magnets have two poles, north and south. The poles are located near the ends of the magnet, where the magnetic force is strongest. By testing different shapes of magnets with iron filings, you can identify the location of the poles. Understanding poles is essential for experiments and for using magnets in practical applications such as compasses and motors. Magnets have been used for centuries to find directions. In ancient China, a chariot with a rotating statue helped emperors navigate by always pointing south. Today we use compasses, which contain a magnetized needle that aligns with the Earth's magnetic field. By suspending a bar magnet and observing its direction, you can find north and south just like explorers did in the past. Freely suspended bar magnet always aligns itself in the north-south direction. This property is used in compasses and helps travelers find their way. By marking the ends of a magnet and rotating it, you'll notice it always returns to the same direction. This experiment demonstrates the consistency and reliability of magnets in navigation. Compass is a small box with a glass cover and a magnetized needle inside. The needle rotates freely and points towards north and south. The compass dial is marked with directions, making it easy to find your way. Travelers and sailors have relied on compasses for centuries, and you can use one to explore your surroundings and learn about direction finding. You can make a simple compass at home. Magnetize an iron needle using a bar magnet, then insert it through a piece of cork or foam. Let the cork float in water, ensuring the needle doesn't touch the water. The needle will align itself in the north-south direction, just like a real compass. This hands-on activity helps you understand how compasses work and the role of magnets in navigation. Magnets can be made by rubbing a bar magnet along a piece of iron multiple times in the same direction. After 30-40 repetitions, the iron bar becomes magnetized and can attract pins or iron filings. This method is simple and effective, allowing you to create your own magnets for experiments and practical uses. Try making a magnet and test its strength with different objects. Magnets can attract or repel each other depending on their poles. Opposite poles north and south attract, while similar poles north-north or south-south repel. This property is demonstrated by placing magnets on toy cars and observing their movement. Understanding attraction and repulsion is key to using magnets in motors, generators, and other devices. When the north pole of one magnet faces the south pole of another, they attract and move towards each other. This principle is used in many applications, from magnetic locks to electric motors. By experimenting with magnets, you can observe how opposite poles create a strong pull, bringing objects together. When two magnets are placed with similar poles facing each other, they repel and push away. This repulsion is visible in experiments with toy cars or suspended magnets. Repulsion is important in designing devices that need to keep magnets apart or create movement, such as maglev trains and certain types of sensors. Magnets can lose their properties if they're heated, hammered, or dropped from a height. To keep magnets strong, store them properly. Bar magnets should be kept in pairs with unlike poles together and separated by wood with soft iron pieces across their ends. Horseshoe magnets need a piece of iron across the poles. Keep magnets away from electronics like mobiles, TVs, and computers to prevent damage. Maintain their strength. Magnets must be stored carefully. Bar magnets are kept in pairs with their unlike poles together, separated by wood and soft iron pieces across their ends. Horseshoe magnets require a piece of iron across the poles. Proper storage prevents magnets from becoming weak and ensures they last longer for experiments and practical uses. Magnetite is a natural magnet found in rocks. Magnets attract materials like iron, nickel, and cobalt, which are called magnetic materials. Materials that do not get attracted are non-magnetic, such as rubber and paper. Each magnet has two poles, and a freely suspended magnet always aligns in the north-south direction. Opposite poles attract while similar poles repel. Let's test your knowledge. Artificial magnets are made in shapes like bar, horseshoe, and cylindrical. Materials attracted by magnets are called magnetic materials. Paper is not magnetic. In olden days, sailors used magnets to find direction. Magnets always have two poles. Similar poles repel, opposite poles attract, and bar magnets point north-south. Compasses help find directions, and rubber is non-magnetic. Magnets are used in many ways: finding lost metal objects, sorting materials, and making intelligent toys. For example, a doll with a hidden magnet in its hand can pick up objects made of magnetic materials. Magnets are also used in compasses, motors, and electronic devices. Their unique properties make them essential in science and technology. Try these activities. Use a compass to find the direction of windows and doors in your house. Place two bar magnets with their north poles together and observe the repulsion. Help a carpenter separate iron nails from wood shavings using a magnet. These hands-on experiments make learning about magnets fun and practical. Magnets have inspired stories and fantasies, such as the floating island of Laputa in Gulliver's Travels. Could magnets be involved in such magical tales? The mysterious and powerful nature of magnets sparks imagination and creativity, making them a favorite topic in both science and literature. Let's summarize what we've learned. Magnetite is a natural magnet. Magnets attract materials like iron, nickel, and cobalt. Non-magnetic materials do not get attracted. Each magnet has two poles, north and south. A freely suspended magnet aligns in the north-south direction. Opposite poles attract, similar poles repel. Magnets are used in many practical and fun ways. Keep magnets strong, avoid heating, hammering, or dropping them. Store magnets properly away from electronics. Bar magnets should be kept in pairs with unlike poles together, separated by wood and soft iron pieces. Horseshoe magnets need a piece of iron across the poles. These precautions ensure magnets remain effective for experiments and everyday use. Magnets are fascinating tools that combine science, technology, and imagination. From ancient discoveries to modern applications, magnets help us explore, create, and solve problems. Try the suggested activities, experiment with magnets, and observe their effects in your daily life. The world of magnets is full of surprises. Keep exploring and learning.